Let's see this question. So we're trying to find square root of 3 minus square root 2 squared plus 1 over square root of 3 minus square root 2 squared. So this kind of irrational numbers, first is a difference, and inside the radicand default by 1. Right, default by 1. So this kind of irrational numbers has a feature. So that means 1 over a equals to its conjugate. Its conjugate means the square root of 3 plus square root 2. Let's see why. Let's see why. So when we flip a, the 1 over a equals to 1 over square root of 3 minus the square root 2. And we can multiply by its conjugate, square root of 3 plus square root 2. Remember, this is the difference of two squares. And of course, we have to multiply in the numerator and in the denominator, right? For expression, we can only multiply by 1. And 1 is anything divides itself. So the denominator, so the numerator is 1 times square root of 3 plus square root 2. But the denominator is the square root of 3 squared minus the square root of 2 squared. Difference of two squares, right? A plus b times a minus b, that's a squared minus b squared. Well, the numerator is just square root of 3 plus square root 2. The denominator is the square root of 3 squared, which is 3, minus square root 2 squared, which is 2. 3 and 2. 3 minus 2 is just 1. So we get square root of 3 plus square root 2. So it's not only for this, this is for any. If we have a equals to square root of, let's say b plus 1 minus square root of b, and the 1 over a is always square root of b plus 1 plus square root of b, and vice versa. Okay, if a equals the square root of b plus 1 plus square root of b, then 1 over a will be square root of b plus 1 minus square root of b. Right, so this is a very cute feature to remember. Okay, now it becomes easy, right? And also remember, let me change my color. So now, also remember another feature, a plus 1 over a squared. The perfect square with multiplicative inverse, right? Because a and 1 over a are multiplicative inverse, which means if we multiply a with 1 over a, we get 1. So that makes them to be multiplicative inverse. If we square this, we get a squared plus 1 over a squared plus 2. Right? First one square, a squared. Second one square, 1 over a squared. Plus 2 times a times 1 over a. A times 1 over a is 1. So 2 times 1 is 2. So the middle term is 2. Now let's see this. So a equals square root 3 minus square root 2. 1 over a equals square root 3 plus square root 2. So if we add a and 1 over a, in that case, a plus 1 over a, we get a square root 3 plus square root 3, which is a 2 square root of 3, right? We have this one plus this one, there's 12 there. But then we have minus radical 2 plus radical 2, that becomes 0. So now we can square both sides. Square both sides, we get it above one. We get this. We get a squared plus 1 over a squared plus 2. And this side we get 2 squared 4. 4 times 3, 12. So then we just subtract 2 on both sides. So we get 12 minus 2, that's 10. So a squared plus 1 over a squared is 10. So the answer for this is 10. So you see this question, we need to know two things. One thing is the difference of two radicals. If the radicand are consecutive, then it's multiplicative inverse, just a conjugate of that. And then we want to remember this formula. So basically use those two features. for this question.